Hello, good morning, everyone. Please let me know who all are there. Hi. Good morning. Krishna is there. Lakshmi, good morning. So this is the part 3 of GATE score booster session of transportation engineering. We have already covered part 1 and part 2, in which we have discussed most of the important topics of highway geometric design and traffic engineering, right? So as we know, majority of the questions which are appearing in GATE exams will be from highway geometry design and traffic engineering. We have almost finished the traffic engineering, but a last point which I told you in the part 2 session, if anyone who is watching the video have missed to watch part 2, don't worry, we are going to just give an introduction regarding what we studied in the part 2 session. So we were discussing regarding some signal designs and all. We'll just continue that. Then we will finish the remaining portion. Pavement material and design. Then airport and railway also. Okay. So I'm just waiting for a few seconds so that more students will join. Bhagyashree, good morning. So after this session, you will be having environmental engineering session also. So everyone, please stay tuned and subscribe the channel and click on the bell icon. You will be getting those notifications whenever you are getting the live classes of various subjects. Okay. Yes. So I'm just giving a basic introduction. I mean, something like what we were discussing in the last session. We have seen what is signal cycle. We have seen what is optimum cycle time. Regarding Webster's method also we have studied. Effective green time, we have seen what is effective green time, what is the equation. We have solved the questions also. Then capacity of signalized intersection, that also we have seen. Then in the last session, I have mentioned what is the equation of average delay per vehicle, and I told you to calculate also, those who were attending the session. And so equations also we have discussed for optimum cycle time, effective gain time, capacity of a particular phase or lane, then average delay. So we have discussed one question in which we have solved all those equations, all those concepts. Then I told you for the first phase, we were getting a delay of 17.7 seconds. So those who are not watching it or those who have not attended that, please check that particular question and you just substitute these values and check whether you are getting the average delay as 17.7 or not. Okay. So this was the question which we have discussed and we have calculated the effective green time. Before that, we calculated the optimum cycle time. Then we calculated the capacity of that particular phase or particular lane. Then I told you to calculate the average delay per phase, I mean average delay per vehicle in that first phase. Then the answer was coming to be 17.7. So were you getting, those who have, I don't know how many of you have attended that particular session. So you just check it, okay? So direct substitution, we have solved all these questions, effective green time, capacity, average delay and all. So like this, phase 1, all the values we have calculated, C0 we calculated, effective green time we calculated, Q and S also was given in the question, we were getting 17.7. Okay. So till this we have discussed till part 2. Now I told you the average delay per vehicle they can ask in various form. The first one is by like this, by giving the data in the question, all the data they will give in the question like this. From this, we are going to calculate effective green time, cycle time, then substitute this normal flow and saturation flow. Okay, so those who missed that video, just watch it later. It is available in the channel. Okay, now in case if they are giving in terms of some graphs like this, you might have already noticed such graphs in the previous GATE papers. There are two ways of graphs they can give for the calculation of average delay calculations. You can also put it in under the heading of Q analysis. So the type 1 is, as we have already seen, nothing but giving the data in terms of sentences, then we can calculate. The second thing is giving a graph, which is nothing but, so this graph is actually stands for, one second. Yes, they are giving two graphs, one graph. So these are two lines. So one line stands for the arrival rate of vehicle. Then the other line stands for the departure rate of vehicle. So they will give two graphs or two lines like this or two rates like this. One is arrival rate, the other is departure rate. Now this is nothing but our time. And on the x-axis, we have cumulative number of vehicles. We can also call it as Q length, okay? Cumulative number of vehicles also can be termed as Q length, okay? If they are giving such questions, and if they are asking us to calculate what is the average delay per vehicle, it is very easy to calculate actually. If I am simply taking that graph here for explanation. Yes, before that I will tell you what is the second one. They will give you the arrival rate. They will give you the arrival rate, but the second one is not at all the departure rate. If it is departure rate, that also will keep on increases. Okay, that I will tell you later. The y-axis and x-axis are same, time and Q length, or time and cumulative number of vehicles. Okay, so if they are giving a graph like this, which is having arrival rate and departure rate on a cumulative number of vehicles versus time graph, or Q length versus time graph, we can easily calculate what is the value of arrival rate, what is the value of, normal flow, what is the value of saturation flow, all other things we can calculate from this. Listen properly how we are going to calculate. Now, see, this arrival rate means at what rate vehicles are coming into an intersection. So that can be any value. Sometimes a less number of vehicles may come, sometimes more number of vehicles may come. So practically it keep on changes. It will not be a uniform rate what we have drawn. So, okay. So the arrival rate may be some arbitrary shape. Okay. For the analysis, according to Webster's method, we are assuming that it is a uniform rate. So that's why we have drawn a straight line. Okay. For the simplicity in analysis, practically it can be any shape. Okay, it can be a curve or anything. And the departure rate also, see Q and S value, we are actually assuming it as a constant value. Now in the questions also, practically it may be different. It keep on changes and all. Sometimes more vehicles will come, sometimes less vehicles will come. On an average, we are taking a particular constant value. Similarly, departure rate also they are giving. Properly listen. If I am telling the arrival rate is constant and it is going like this, departure rate, when the vehicle will start departing, when the vehicle will start departing from a particular intersection, at what signal, or when they will be in the queue. Please comment. Yes, green signal. Yes, very good. Which means in the red signal, suppose if I'm starting from time 0, in the red signal, all these vehicles are under queue. So actually there is a line here also for this departure rate, but it is on the x-axis. That's why we are not drawing it. Okay. So till this red signal, till the green signal means throughout this red signal, vehicles will be under queue. They are not departing anything. We are just drawing the departure rate. So whenever this red signal is finished and the green signal is starting, then what will happen? Then the vehicle will start departing. Understood? So it keep on increases. Is it clear? So after green, we will be having some amber also. Okay. I don't know whether you are able to watch that on the screen. Simply if I am just, do you remember what is this signal time? Green plus amber. Do you remember what was green plus amber? Yes, effective. Very good. This is known as effective green time. So sometimes they will give green amber separately, or they can give effective green time. Okay. Now can you tell me what will be this point? Red signal plus green plus amber, or red signal plus effective green. What is this? What will be this particular time? Very good. Optimum cycle time C0, or simply cycle time. According to Webster's method, we are taking optimum cycle time. Now you listen. if I am telling, so this is the cycle time, na? So this intersection point, this intersection point can be either corresponding to optimum cycle time, or can be before the optimum cycle time, or can be after the optimum cycle time also. Okay. So if it is corresponding to optimum cycle time or before, like this, we call it as a saturation system. See, these things they will not be asking, just for understanding. Okay, maybe somewhere if you are seeing in the question data, don't get confused. Somewhere if they are giving saturation system, don't get confused, which means that intersecting point is before the C naught value or corresponding to C naught value. If that intersecting point is after this C naught value, time C naught, then it is known as unsaturated system. So what do you mean by this saturated system? All the vehicles are actually departing even before the green signal is over, which means even after all vehicles are clearing the intersection, we still have some time. See, this much time, green time there, where there are no vehicles to depart. All the vehicles which were in queue have already cleared the intersection. This is the meaning. Okay. And in case if it is touching, I mean exactly if it is coming on the C naught, it means the moment green time is over, all the vehicles are cleared. That is the meaning. And if it is touching after the C naught value, which means uh, all the vehicles were unable to clear the intersection, means maybe I'm in the queue. There is a red signal and I'm in the queue, back side of the queue. Green signal started, so all the vehicles started moving. I am also moving, but before I am reaching the intersection, again red signal came. That happens now generally in busy intersections and all. You may be getting two red signal, even before crossing the intersection. In such cases, if we are drawing this graph, this intersection point will be after this C naught. Okay, something like that. That much in detail we don't require for such problems for gate examination. Simply remember these things. Okay, it can be before C naught, it can be on C naught, or it can be after C naught also. This intersecting point. Now, generally, according to Webster's method, we are going to design. So, according to Webster's method, we can take that intersection point is on the, that's what Webster has told. Properly, we are going to design what is C naught. So, for simplicity, this is what most probably they will give. If not also, no problem. Okay, wherever it is, we can calculate the same method only. As of now, I am taking this value as C naught. Means exactly when the green signal is ended, green signal plus amber signal is ended, we can put it like that. Okay, all the vehicles have departed. This is the meaning, or I can call this as the effective time. And if I am taking this cumulative value, okay, let it be there. I'm telling the concept now. We got the arrival rate line, we got the departure rate line. To calculate, if they are asking what is the total delay, what we can do, if we are taking the area of this graph between of that portion between the arrival rate and departure rate, whatever shape they are giving, okay, whether it is intersecting before C naught, corresponding to C naught, or after C naught, whatever, the area between those two lines, or the area between those two, arrival rate and departure rate, gives us the total delay. So can I write area of shaded portion? Area of shaded portion. This is nothing but total delay. Now, how can I calculate the average delay? How can I calculate the average delay? Nothing but this shaded area which gives us the total delay divided by, tell me, total delay of vehicles, total delay of all the vehicles is area of the shaded portion. Now, what will be the average delay? Yes, that's it, divided by n. What is this n? Number of vehicles. That's it. So simply you write there, it is nothing but the number of vehicles. But how we know how many vehicles are there? Then that should be given in the question. Nothing but simply I'm putting number of vehicles n only. Okay, you just write like that. Number of vehicles n, that will be given here. This is nothing but number of vehicles n. Is it clear? Is it clear? Yes, that's it. Divided by the queue length, nothing but that particular value. Is it clear? If they are giving such a graph, very easy. we just have to take the area of that shaded portion. How can we take the area of that shaded portion? How can we take the area of the shaded portion? How can we calculate that? It's not a perfect right angled triangle and all, na? And we don't know what is the base width, nothing, perpendicular distance. What we can do? We have a bigger triangle here, na? With the base time equal to this x-axis, height is this. So we have a bigger triangle like this. Na? So from that bigger triangle, if I am minusing this unshaded portion, I will be getting the shaded portion. Correct now? So that we can do easily. Yes, that's it. Very good. Full triangle minus effective green time triangle. That's it. Okay. This is nothing but effective green. This will be effective green only if it is C0. If it is meeting before C0 and all, then it is not effective green, then correspondingly we have to take. That's why I told wherever it is meeting, if we are studying that concept, area of the shaded portion, we can easily calculate it from the particular graph. Is it clear? Okay. One more extra point I'm telling you, if it is meeting at C0, okay, then finally, if you are calculating this data, finally you are going to get the average delay is equal to red time divided by 2. That you can just calculate that. Keep in mind, if it is meeting at C0, then it will come as red time divided by 2. In unsaturated system and all, this may not be coming exactly same. And one more thing I'm telling, if it is at C0, one more equation we can use, nothing but what was our delay? C0 by 2 into 1 minus G effective by C0 the whole square. The equations which we have seen in the last video, Q by S. This equation, do you remember? The equations which we have written. This equation we can use if they are meeting correspondingly at C0. In other cases, we cannot use this equation, only if it is meeting at C0. Or leave it, no issue. We can just remember that shaded portion divided by N is the average delay. That's it. Okay. Understood? Is it clear, everyone? For example, if you want a question, okay, simply example, you just take a question, like just take this is 50. Take this red signal as 26 seconds. Takes optimum cycle time 60 seconds. Can you just calculate and tell me the answer? Red time is equal to 26 seconds. Okay, I'm telling like this, actual green time, or correspondingly they are giving this is 60 seconds. Actual green time, maybe let it be, how much I should take? 32 seconds. Amber is equal to 2 seconds, let it be, which means effective green is 34. So 34 plus 26, 60 seconds. Okay. Now, can you tell me what is the average delay, everyone? This is actual green. So effective green will be equal to 34 seconds. Either you can calculate using this equation. Later you calculate, not now. Just calculate the area of the shaded portion, then tell me. Yes, very good. Very good. Are you getting 30 seconds? Everyone, please comment. Are you getting 30 seconds? 13. Very good, Krishna. Very good. What about others getting? Yes, yes. Very good. Now see, if you want to calculate this equation, then also you are going to get, because it is meeting at C0. To calculate Q and S, what we can simply do, arrival rate stands for Q. How much will be Q? 50 vehicles are meeting at how much seconds? Total, okay, tan theta, that will be 60. So this is our Q value. You can convert into vehicles per hour also, but not required. We just require Q by S ratio. So put it into vehicles per second only. S will stands for the departure rate. What is the departure rate? That is also corresponds to 50 seconds. What is that time? Effective green time on the x-axis. What is that value? 34 seconds. So if you are taking Q by S ratio, we are going to get 34 by 50. No, sorry, 34 by 60. That is nothing but G effective by C0 ratio. So finally, everything will get cancelled. You are going to get exactly red time by 2. Are you getting same? Yes. Thank you, Vishal, for your comment. I'm happy that you are getting the benefit of the video. From the video. Understood? Yes, very good. Understood? So this is one type of question which they can ask by giving arrival rate and departure rate. So always it will be starting from 0. Okay. The next thing, instead of giving you the departure rate, they can give you the arrival rate. From there, they can give the next graph. Okay, not starting from 0, from there. So like this, then it is going to be like a triangular shape, means like this, increasing, then decreasing, not like this. So in the second one, very easy. See, actually, if they are giving this graph, we can convert into this first graph and calculate in the same way. But sometimes you may make mistake. So better don't study like that. In a better, simple way, we can study. You are not going to write university exams. Now, if it is university exam, then actual procedure is you have to convert this graph into this graph, then calculate it. But for GATE exam, so is going to method out. Simply, if they are giving this graph, for example, if I am taking, according to my example, suppose this is 30. Okay, I'm taking that graph below and just solving the question. For example, through an example, we can just, where it is, yeah. For an through an example, just we can understand. If they are giving such a graph, what we need to do, let it be this is 30 number of vehicles, same x-axis, same y-axis. Either they can give in terms of Q length, or they will give another name, cumulative number of vehicles. Now tell me, average rate keep on increases. Here the vehicles start departing actually. Okay, average rate keep on increases. Here the vehicles start departing, means Q length started decreasing. When the Q length started decrease, please comment everyone. Please comment everyone. I will come to your doubt after explaining. When the Q length will start decreasing, at the end of which signal? At the end of which signal Q length start decreasing? At the end. Yes, starting of the green, which means this is corresponds to red signal. So here we are having the green signal. Understood everyone? Yes. And I told you, either this can be C0, or either it can be before C0 or after C0, whatever, we don't care. Okay, leave it. If it is C0, only one advantage we have is that we can use that equation, C0 by 2 into that equation we can use, that's all. Now, in such a question, simply you listen, arrival rate we got. What is this arrival rate? Q is equal to, similar to previous question. See why I told you these things and all. This Q and S, here we are directly getting the shaded area. No need to calculate using this. But maybe if they are giving a figure like this and asking you what is the arrival, what is the normal flow? What is the saturation flow? Then you have to calculate like this. Okay, 1 year, when they asked a question, using this graph, they asked the normal flow, saturation flow and all. In the previous GATE question, you might have already seen that. So tell me, what will be the Q value, everyone? 30 vehicles divided by, okay, if I am giving the graph as this as 60, according to my value I'm writing, so that I can compare. 60, this is 80. Okay, previously we have taken corresponding to C0. Now I'm taking something, let it be C0 is 92 seconds, which means it is meeting even before 80. Okay, it's meeting somewhere, means all the departure, all the Q length is becoming 0 even before the effective green time. So this is complete effective green time because optimum cycle time is 92. So even before the green time, all the vehicles are departing and Q length is becoming 0, which is on the x-axis. Clear? Now tell me, 30 vehicles divided by 60 vehicles. Yes, thank you. 0.5 vehicles per second. Either you can convert this into, how can I convert this into vehicles per hour? In 1 second, 0.5 vehicles means in 1 minute into 60, 1 minute into again 60. So it will become 3600. So 1800 vehicles per hour. And if they are asking what is the normal flow, we can do like this. Clear, everyone? Let it be there. Now, if they are asking the saturation flow, in the previous case, they were giving like this. From 0, it is going like that. If they are giving like this decreasing, then what we can do? Can I take simply 60 seconds divided by what is their corresponding time? Can I take simply like this? Can I take like this? 30 seconds divided by 20 seconds? Can I take 30 seconds divided by 20 seconds? This is the change. If they were giving like the previous figure, then we can directly take the tan theta, but this is wrong. Sorry. How we should take? 30, sorry, not 30 seconds, 30 vehicles. Okay. Now what is the change here? 30 vehicles are there. 20 second is also same. But the numerator is having a slight change. What is that slight change? We have to give. Properly listen everyone. 30 vehicles are there. Now, in this 20 seconds extra, in this 20 seconds, more vehicles also will be keep on coming. That is the only thing you have to check. What you need to do, Q value you can easily take. While taking S value, what you have to do, this 30 divided by that particular tan theta you are taking, 30 divided by 20. But in the numerator, what will come? In this 20 seconds, how many extra vehicles are coming? That also you have to check. Tell me, in 20 seconds, how many more vehicles will arrive? Very good. How can we calculate? Arrival rate, we already calculated it as 0.5 vehicles per second. That's why I told you, we can either, if they are asking in vehicles per hour, we can do, or simply keep it 0.5 vehicles per second. In 1 second, 0.5 vehicles. Then in 20 seconds, how many vehicles will be there? Everyone comment. In 20 seconds, how many vehicles? 0.5 vehicles in 1 second. Then in 20 seconds, we'll be having 0.5 into 20. Is it clear? Yes. 10 extra vehicles will be also coming. Clear? If they are giving such a graph, this is what we have to do. If it was in the previous case, like from starting from 0, if they are giving, then directly you can take tan theta. Clear, guys? So what it will be? 30 plus 10, 40 vehicles by 20 seconds, nothing but 2 vehicles per second. You can convert into vehicles per hour also. You will be getting then 2 into 60 into 60, 7200 that you are going to get. Clear? This is how we are going to calculate it. Is it clear, everyone? Now, in such a type of question, I told you in the previous case, we can use that equation correspond to C naught only. If they are giving such a type of data, then we can easily calculate delay using the normal equation. C naught by 2 into 1 minus G effective by C naught, the whole square. Everyone calculate and tell me what is the answer we are getting? Divided by 1 minus Q by S. Everyone calculate and tell me how much you are getting. C naught is 92. 1 minus effective green time is how much? 92 minus 60, 32. Properly calculate. I am not writing everything. Please tell me what is the answer, everyone. Delay. If I am writing, then you will copy paste. Don't look at the screen. You just calculate it. Don't forget to put square in the numerator. See, if you are converting into vehicles per hour or vehicles per second itself, we are taking the ratio. So no need to convert into vehicles per hour. But if they are asking in the question something, what is the normal flow? Then convert. Tell me how much. Everyone please comment. Yes, very good. 26.08 seconds. Enough? Getting the same answer? Everyone? Properly look at the data, Krishna. 26, na? Yes. Don't forget to take the square and all in the numerator. Yes, very good. Thank you. Very good. Yes. Understood? Okay. These are some. This is one request which I got under the every video which I have done in YouTube and all. Q analysis. Okay, understood? This is the most simple way. Clear? So 2 types of graph. Understood how to solve such questions if they are asking? Clear, everyone? Everyone please comment in the comment box. Is it clear? Yes, very good. Very good. Thank you. So that is it. That is the end of traffic engineering. Now, yes, one more point I will tell you. Something very important. Yes, very good. Thank you. Thank you. Time headway and space headway. We have 2 equations. Time headway equal to 3600 by flow. Space headway equal to 1000 divided by density. Very, very important equation. Now see, sometimes they will directly ask the question for 1 mark. Already previous gate questions came. They will give you the headway, time headway. They can ask you the flow. They can give the space headway. They can ask you the density. Very important. The units are very important. Flow should be in vehicles per hour. Density should be in vehicles per kilometer. Then only these numbers, these numerators, you can use. Very important. Now, the application of this, one type of question will be directly giving the data, asking the other one. The application of this, they can give you the saturation time headway in the question. If once they are using the word saturation time headway, the corresponding flow will be saturation flow. Where you have seen this saturation flow? Where you have seen this saturation flow? Comment. Signal. Very good. In signal design, just we have seen a S value. Yes. And just now we have seen Q by S and all. In capacity equation we have seen. If you are going back where it is, we have seen equation C, capacity equal to S into G effective by C naught. In part 2, we have solved some questions. Those who missed that video, later you can watch. So instead of giving this S value, in this question, we have calculated this time, this S value was given in the question. Instead of giving this question, this 1900 in the question, they can give saturation time headway in the question. Using that, we have to calculate. For example, if I'm telling you, 1 second, 1900, yes. If they are giving in the question that the saturation time headway is equal to 1.895, for example, this much seconds. How can we calculate this S value then? Nothing but 3600 divided by saturation time headway. So if you are doing this calculation, you will get approximately 1900. Is it clear now? Okay, something like that they can give. Instead of giving you the saturation flow value, if they are giving what is the saturation time headway, then using that we can calculate it. Is it clear, everyone? Please comment yes or no. Please comment yes or no. Yes, very good. Thank you. Now, similar to that, we know space headway equal to 1000 by density. If they are telling that the space headway under jam condition, traffic jam condition is something. For example, if they are telling spacing under traffic jam condition is maybe 10 meters. Spacing under traffic jam condition is 10 meter. Then the density corresponding to traffic jam we can calculate. How much it will be? 1000 by 10, 100 vehicles per kilometer. Where you can use this concept? Where you can use this concept? The density under traffic jam condition. Where you can use this concept? Very good. Kj. We have already seen questions. Traffic jam Kj into Vf divided by 4 and all. Clear? In the last year video, I told you gate score booster session done in the last year. I have done a question based on this by giving the spacing under traffic jam condition, then calculate the maximum flow. You can watch that video. Okay, last year you can simply search a gate score booster or gate score booster session, the Gate Academy, something like that. You'll be getting that video, or I can comment in the comment box also. Or those who are getting that video, you can comment in the comment box so that other students also getting the benefit. Okay, help the other students, then definitely the Almighty will help you also. Okay, yes. So this can be asked in the application. Application will be in the maximum flow calculation using Kj. Saturation flow. This can be okay in between. Yes. Okay. The saturation flow can be asked in the capacity calculation. We have used the Q and S in the calculations to give this S value. Instead of giving this saturation flow directly, they can give saturation time headway. Okay, Balakrishna, I hope now you understood. If not, you just watch the part 2, then you will understand it better. Okay, instead of giving S value, they can give the saturation. Is it clear now? Okay. Yes. So we are going into the payment materials portion. So just read this question and try to solve first of all. Capacity is maximum density. Capacity and maximum densities are different. Okay, we will be getting the capacity or maximum flow. Capacity is nothing but maximum flow only, corresponds to half of maximum density. If you are getting any doubt, you can just watch the previous video. Part 2 you watch. In detail, we have explained the different types of question also. Okay, don't worry. Yes, keep on practice it. Try to make a short notebook and all, then you will not forget it. Don't worry. Actually, these sessions are actually doing for refreshing the concepts. Okay. Yes, I hope you have gone through the question. What we need to calculate finally? The radius of relative stiffness of the slab. Properly listen. This question is combined to pavement material and pavement design. We have an equation, radius of relative stiffness. Little bit complicated equation, but if they are asking a question, that will be very direct. Eh cube divided by 12k into 1 minus mu square whole raised to 1 by 4. Since the equation is little bit complicated, whenever they are asking question, they will give the data directly. Okay. But in this question, directly, instead of directly giving you the data, I have just made a twist just to incorporate two concepts into one question. That's it. So E is nothing but the modulus of elasticity of concrete that they have given in the question, 3 into 10 raised to 5 kilogram per centimeter square. So since it is kilogram per centimeter square, substitute H also in centimeter. So how much is centimeter? 22 centimeter they have given. So 22 cube divided by 12 into K stands for modulus of subgrade reaction. Look at the data whether they have given any modulus of subgrade reaction. No. So K is unknown here. Okay. So K modulus of unknown, modulus of subgrade reaction. I'm putting it there. Now what is this mu? What is this mu? Yes, Poisson ratio. That is not given. Then what to do? That is also not given. Poisson ratio is actually lateral strain by linear strain, something like that. No, you might have studied in strength of materials, but that is also not given. Then what to do? If they are not giving the value of Poisson ratio of concrete, we have to take the value, how much? 0.15 if it is not given. Okay, so that is the next point you should remember. They may be giving you, if they are not giving 0.15, not 0.5, 0.15 if they are not giving, to calculate the modulus of, to calculate the radius of relative stiffness of concrete. Okay, so take it as 0.15, not 0.5, 0.15. Okay, so that's it. And the next point, don't forget to take this raised to 1 by 4, very important. Okay, so these are the things you should keep in mind. Most probably they will give, if they are giving some other value, 0.16 or something, if they are giving, take as it is. If not given, then assume 0.15. Now what is our challenge here? We don't know what is K. All other values have already directly given. Now see, this E value is in kilogram per centimeter square. Then H value is in centimeter. So centimeter cube we have. Now divided by, now in which unit we have to substitute? The modulus of subgrade reaction unit will be Newton, kilogram, kilonewton, anything, divided by millimeter cube, centimeter cube, meter cube, like that. So better you substitute everything in same unit, then only we can cancel everything. So here you listen, kilogram and kilogram will get cancels. Here centimeter square we have, here centimeter cube we have. So centimeter square will get cancels, 1 centimeter will remain. This centimeter square will go up. I mean, did I make any mistake? Once again. Sorry, yeah, here centimeter cube. Okay, centimeter cube. So this centimeter cube will go up. So finally we'll be having centimeter raised to 4. Here we have 1 by 4. So finally your answer will be in centimeter. Okay. Now, how to calculate this K value? That is our challenge. So how to calculate this K value, modulus of subgrade reaction? Remember, modulus of subgrade reaction is equal to pressure divided by delta, or P by delta. Now, what is this P and what is this delta? Always you have to remember delta value is constant, 0.125 centimeter. Most probably they will give directly What is this P value? This is nothing but pressure value. Pressure corresponds to pressure or stress. Stress corresponds to this particular delta value 0.125. Most probably they will give in the question itself, or they will give the load value. If they are giving the load, how can we calculate the pressure value or stress value? We know stress is equal to load by area, very easy. But how can we calculate the area? Yes, very good. How can we calculate the area? They have given the diameter of the plate. We'll be using a circular plate only for plate load test. The diameter is given 45 centimeter. Then how can I calculate the area? Yes, area of the circle pi by 4 d square, as simple as that. But which load I have to take? Sometimes directly they will give in the question, the load corresponds to 0.125 centimeter, deflection is this much or deformation is this much. If they are not giving, what we have to do? Yes, very good. From the table also we can take. So why I have given the table? Just to let you understand, just to make you understand which deformation we have to select. Now tell me which deformation you will select. First one, second one, third one, or fourth one. We told it is 0.125. No? The value is not there. 0.125 is not there. What to do? It is given in millimeters. That's it. The next point, very important. 0.125 is in centimeter, which means how much millimeter? 1.25. Understood? Something like that. They can also give in the, see, if they are giving the table like this, in the table they can give 0.125 mm also. So don't make mistake in the examination hall in that tension. Okay, in the examination you definitely will be under tension. So don't make mistake. Properly look at the units. 0.125 centimeter means 1.25 millimeter. Okay, so this is the next point you have to take care in the examination hall. So we have to select this particular value, 2810 kilogram. So how I am going to calculate that P value? 2810 kilogram divided by pi by 4 into d square is 45. So I will be getting kilogram per centimeter square. Is it clear, guys? Okay. Then you have to divide with, I hope it is clear. So K is equal to pressure divided by delta, whereas this pressure is 2810 kilogram divided by pi by 4, d is 45 centimeter. So I will be getting in centimeter square. So divided by delta value is 0.125 centimeter. See, this is why I told you kilogram per centimeter square by centimeters. Then we will be getting kilogram per centimeter square. Tell me how much is this value? Everyone, can you tell me how much is this value? Everyone, please comment. Yes, are you getting? No need to calculate P separately. Directly you take divide by also. This pressure value will be around 1.7668. Yes, thank you. Then divided by this numerator, sorry, denominator will be getting 1345 approximately. Are you getting the same answer? Are you getting the same answer? Yes, thank you. So can I substitute that value here? Can I substitute that value here? 14.1345. Can I substitute here? Can I substitute and calculate the answer? You can substitute and calculate the answer, no problem. But you are going to get 0 mark or negative mark, as simple as that. That is the next twist which can happen. What is that? What is that? You have to properly look at the diameter which they have given. We have to use the standard plate. Yes, Krishna, very good. We have to substitute the value corresponding to the standard plate. That itself can be a question for 1 mark. What is the standard plate? That is 75 centimeter diameter plate. But maybe practically if this diameter is not available, what we'll do, we'll take some smaller plate, either 30 centimeter or 45 centimeter and all. Then what we need to do, the whatever we got is corresponds to 45 centimeter dia. That we got it as 14.1345 kg per centimeter cube. Now what we need to do? We have to convert this value corresponding to 75 centimeter, and that value only we have to substitute there. How can we convert? Very simple equation. K1 A1 is equal to K2 A2. This is the equation that you can see in the code book. That's why I have written like that. This A1 A2 stands for radius of the plate, or nothing but simply diameter divided by 2. Diameter divided by 2. Simply you take K1 into diameter is equal to K2 into diameter. That is also same. In the standard code book that is given, K1 into corresponding radius is equal to K into corresponding radius, which means 14.1345 into corresponding radius is 45 centimeter by 2. You simply eliminate that 2. We don't require that 2 because 2 and 2 will get cancels. That is equal to K corresponding to 75 into 75 centimeter by 2. So 2 and 2 will get cancels. Just leave it. We don't require that. K 75 will be equal to what? Everyone please calculate. 14.1345 into 45 divided by 75. Everyone. Yes, thank you. 8.48 kg per centimeter cube. That's it. Getting? Everyone? That's it. Okay, so this value only we have to substitute back into the equation. So substitute that value 8.48. So you substitute that value. Very important. If they are giving, suppose see, if they are giving in Newton, for example, if they are giving in Newton, if it is Newton, then it will be this into 9.81. If they are giving that value in the question, then finally you will be getting some value that you have to convert into kg. Okay, because the E value is in 3 into 10 raised to 5 is given in kg per centimeter square. Okay, so that properly you have to check. If this is in Newton per meter square, for example, then this one also, the K value should also be Newton per, like that. Then only it will get cancels. That's why I have shown this conversion here. Okay, you should remember. Okay, kilogram divided by 9.81 will be in Newton. Okay, yes. So finally, how much you are going to get if you are substituting 8.48? So 8.48 is correct. So finally, your L value will be, yes. Are you getting 75.28 around? Are you getting around 75 point something? Yes, very good. So this question they told round off to 1 decimal. So they will give a range. Okay, don't worry, they will give a range. But don't think that according to, if you are putting 14 point something, you are getting a wrong answer. Definitely that will not be in the range. They may give something like 74.1 to 77.1, something like that. Okay, or somewhat good range also they may give because cube and so many calculations are there. Clear guys, are you getting around 75? Yes, that's it. Understood? What is the concept of plate load test? Clear? Yes, very good. Shall we move to the next question then? In this question, we have used the two concepts, plate load test, then modulus of subgrade reaction, 3 concept, then radius of relative stiffness. One more concept is there. What is the standard plate? Okay, that also can be one more question. Diameter and deflection also properly remember. 0.125 centimeter, nothing but 1.25 millimeter. Okay, properly check that. Now coming to the next concept important in the pavement material and design, nothing but the Marshall mix design. So properly note down the data. Before you are noting down the data, let me show you some important equations. Nothing but Marshall has given 3 important equations. Nothing but first one is the percentage air void. I will show you the data after some time. Percentage air void, nothing but GT minus GM by GT. Those who have not studied this, just look at this, or those who already studied, just to brush up your concept. GT stands for theoretical specific gravity. GM stands for bulk specific gravity. Okay, or mass specific gravity. M stands for mass specific gravity. Sometimes they will give in the question mass specific gravity, definitely they will give. GT sometimes they will not give. If they are not giving, we have a calculation to calculate. We have an equation to calculate GT. Then percentage voids in the mineral aggregate. Nothing but percentage voids in the aggregate only. This is percentage voids, total percentage air void. This is total percentage void, which means it can be air void or bitumen. The voids which are filled with bitumen. And this is how we calculate percentage VA. We already calculated in the first step, plus percentage VB. Either they will give that percentage volume of bitumen in the question. If they are not giving, we have to calculate like this. We are going to do a question. You will understand what is the calculation. Okay. This is just for voids filled with bitumen. The calculated value of VB in the second part of the equation divided by this total value. Okay. So this VMA is nothing but VA plus VB. That's it. Yes. Now I told you, in case if they are not giving the value of GT, we can calculate using an equation like this. We are going to calculate the value using this equation. Okay. All these equations we are going to use for this particular question. Okay. So just take down the data and try to calculate. If you have already studied, try to calculate how to calculate the percentage air voids. Everyone. See, I'm going into the next level of the question actually, because if you are solving this question, then whatever question they are asking for Marshall mixed design, Marshall bituminous mixed design, we can easily calculate it. Okay. This is the most lengthiest question maybe. So part of this can be a 2-mark question. I have just made it into an MSQ question, going to be a little bit lengthy. But why I've made all these concepts into one question? A part of this can be a 2-mark question. Okay. So once you are doing this question, anything, whatever they are asking, you will be able to solve it. Okay. Now, see, first one, if you are taking, we can solve it together. Okay. Percentage air voids. How can we calculate percentage air void? We have already seen the equation. Percentage air void equal to GT minus GM divided by GT into 100. 100 we are doing for converting into percentage. Now you see, bulk specific gravity, nothing but GM is given in the question, 6.9, sorry, 2.34. GT is not given. We have to calculate using the equation like this, 100 divided by percentage W by G of course aggregate. Before going into that, I can tell you, a Marshall mixed design means we will be having coarse aggregate, we will be having fine aggregate, we will be having some filler material to fill the voids. Still we may be having the voids. So what we will do? We will add some binder. Nothing but to mix the or to bind that aggregates. Okay, coarse aggregate, fine aggregate, filler. If we are using concrete mix, in RCC you will study concrete mix. There we are using water to mix the fine aggregate, coarse aggregate, cement and all. Here we are using bituminous binder. Sometimes they will give binder or they will give bitumen. In the bituminous mix design, we are using binder as, bitumen as the binder. Okay. So sometimes they will tell that bitumen is this much. Sometimes they will tell binder is this much. Both are same. Now, W stands for percentage weight of that particular fraction in the total weight. Most of the time, 99.99% of the time, they will give that value directly in the question. The percentage weight is this much. Okay, they will give for each content how much is the percentage weight out of the total weight of the mix, how much is that fraction, like that. In this question, I have just gone into the next level. Instead of giving that W value directly, I have just given what is the weight value. So what we have to do? Very simple. Calculate the total weight of the mix. Check how much is this 624 gram out of the total weight. Understanding? You please tell me how much is the total weight, everyone. What is the total weight? So simply to calculate this particular W, how can I calculate this W value? So 624 gram is the coarse aggregate. What is the total? Everyone, can you please comment how much is the total value? 624 plus 432, 1200. Thank you. And 1200 gram. Now, one extra point I'm telling here, generally to make a Marshall mix, we generally take 1.2 kilogram of mix. Okay, generally it will be around 1200 gram. You can simply remember that. No one will ask you, but simply remember. That's why I have taken this. So that is W of this one. So we got W of coarse aggregate. You can just divide it with, so you just calculate, okay? W of coarse aggregate is how much? W of fine aggregate is how much? Filler is how much? Generally, this data they will give in the question, bitumen or binder. Generally, they will give, but we were just going into the next level. That's it. So how much you are getting? This will be, you will be getting it as 52%. Multiply with 100, okay? That is in percentage actually. So you have to convert into 100 percentage weight. Okay. So this is 36%, 5%, 7%. Correspondingly, specific gravity is also given in the question. Corresponding specific gravity is given. Okay. Now we can substitute easily. Now you just calculate and tell me how much you are getting GT. How much you are getting GT? Everyone please comment and tell me how much it is. So 100 divided by all value, if we are putting, see, don't put 2.66 divided by 52. Don't make that mistake. It is W by G. Okay. 2.66 plus 36 divided by 2.76. 5 divided by 2.9. 7 divided by 0.99. I hope I have not made any mistake. You are going to get 2.416. Are you getting same? Okay, thank you. So you got 2.416 here. Now you can go back to the equation, substitute there. That's it, as simple as that. We got 2.416. The value is given 2.34 as GM. 2.416 multiply with 100. 3.415. Yes, very good. Now approximately 3.4. Sorry, 3.14. Approximately, are you getting same? Yes, very good. All are commenting the same answer. Very good. Krishna, your answer is absolutely correct. Very good. Okay, 3.145. So what is given in the question? Percentage air void is 6.9. No, that is wrong. Okay, so that's why I told you. See, after doing this so many calculation, you are seeing some another value in the option. So you may get confused whether we have made any mistake or not, whether 6.9 is the actual value. So what you will do, then again you will go back to this and again you will check, you will waste your time. So what I'm telling, properly do it. Okay. If you are again going back to the calculation and doing it again, you will lose so much of time. So whenever you are doing, properly do it and check the calculation. Maybe after B and C and D, you may be getting the right answer. If you are making some mistake, maybe suppose it is actually 6.9, but you made some mistake, then you will get everything wrong. Okay, finally you will understand that if you are getting everything wrong, you will understand you made some mistake. But rather than going back again and checking, whenever you are doing, do it properly. Okay, don't forget to take this W as percentage. Okay, otherwise you will be getting a very bigger value, then also you will understand. Okay, very, very important. One more thing I can tell you. After calculating, you can simply check the calculated value of GT will be always greater than GM. That you can use as a check. If you are getting something 2.2, which means you made some mistake in the calculation. Understanding that you can use as a check. Clear? Yes. Now the second one is percentage voids in the mineral aggregate, VMA. VA we already calculated it as 3.145%. Whether they have given in the question, what is the percentage volume of bitumen in the question? No. Then what we have to do? We have to calculate using this second equation, GM into W by G. It is bitumen. So percentage G of percentage W by G of bitumen we have to take. See, here we have percentage W by G of bitumen. And this is percentage volume of bitumen. We have to take that. Now see, this percentage W stands for percentage weight of bitumen. That is percentage weight of bitumen. This stands for percentage volume of bitumen. Understood? Here, whatever we calculated 7% is actually percentage weight of bitumen. Here in the equation, percentage VB is percentage volume of bitumen. Okay, how can we calculate that? G by G into or bulk specific gravity divided by specific gravity of the bitumen multiply with percentage weight. We can prove this, but not required. So much you are going to get percentage VB 2.34 into 7% divided by 0.99. You're going to get it in directly in percentage 545 because W value we have used in percentage. So this also will be in percentage. So once you are substituting 16.545, yes, thank you. Sorry, 16.545. What is the total value? Percentage VMA will be 19.69, correct? Yes. Everyone please comment how much you are getting. Yes, very good. Thank you. So go back to the 19.7. Okay, correct now? So B option is absolutely correct. Perfect. Now percentage void. See, I told you a part of this question can be 2 mark question. Okay, we are doing the lengthiest question so that you will be confident in whatever concept they are asking. Now it is very easy now. What is percentage VB? The second part, 16.545 percentage. What is VMA? The total value. Out of this total VMA, what is that second part VB? That is the meaning of percentage VFB. 69. Now see, both are in percentage. So it will get cancels. We are going to get a decimal. So to convert into percentage, again we are multiplying with 100. Okay, properly check that. Both are in percentage, so that will get cancels. So finally, to convert, we have to again multiply with 100. 84.02. Enough? If whatever answer you are getting, you please comment there. So 84 point something, yes. So C is also correct now. Perfect. Okay. Yes, thanks for commenting. Now effective specific gravity of the aggregate. How we are going to calculate the effective specific gravity of the aggregate? What are the aggregates here? Coarse aggregate and fine aggregate are the aggregates. Filler, we are adding some dust particles or cement particle we can add. Then binder. So these are the these are the aggregates. Now they are asking, what is the effective specific gravity of the aggregate? We know the specific gravity of coarse aggregate is 2.66. Specific gravity of fine aggregate is 2.76. So to calculate the effective specific gravity, can I simply take the average of those two? Can I take the average of those two? No, we can take it if the quantity of both are same. See, if I am asking you the average velocity and all, what is the average velocity of 100 and 150? 125, because only one is there. If the magnitude, or if there are 3 vehicles with 100 kilometers per hour, and if there are 10 vehicles with 150 kilometers per hour speed, then how to calculate the average speed? Weighted average we have to take. 5 into 150, sorry, 5 into 100 plus 100 into, like that, into number of vehicles also we have to multiply. So here, whenever they're asking the effective specific gravity or average of anything, average speed, average specific gravity, anything, we have to properly check the corresponding quantity also. So what is the quantity here? What we have to do? Percentage W of coarse aggregate multiply with specific gravity of coarse aggregate plus percentage W of fine aggregate multiply with specific gravity of fine aggregate. Now what we need to do? Similar way, we are doing the weighted average of anything divided with percentage of coarse aggregate plus percentage weight of fine aggregate. This is how we are going to do it. Now this is why I told you, suppose if the quantity are same, so whatever is W, whatever is W of FA, if both are same, that will get cancels with this one. We will be getting a 2 here. Finally, it will be divided by 2. So if the quantity are same, generally if we are calculating the average speed and all, simply we divide with the number. Average precipitation we have seen like that. So how much you are going to get? So 52, 2.66, 36, 2.76. Very, very important. Divide with W only. Don't divide with G and make wrong answer. 52 plus 36. How much you are getting, guys? Please comment. Thank you. 2.7 you are getting. Yes, very good, Bhagyashree. Correct. Go back to the given option. 5.42. No, absolutely wrong. We got 2.7. See, if you are taking again multiply by 2, somewhat by mistaking, you will be getting it as 5.42. Okay, so this is wrong. We got 2.7. So what you are getting, which all options are correct? That's it. Clear, everyone? Yes. So a part of this, if I'm asking this question, I think this is going to be like a 6-mark question. You know, so many calculations are involved. Okay. So a part of this can be asked for 2 mark. Clear? All are getting B and C as correct answers? Everyone? Yes, very good. So this is something which is important for Marshall mix design. The other thing which is important is Marshall graphs. So just take a screenshot, or later we can give a PDF, don't worry. These are the graphs given by Marshall. This you have to remember. They can give 4 options in the question. You can see those questions in the previous gate questions also. They can give one graph and they can ask, what is this graph? Or they can give which of the following represents the graph between, or Marshall graph between flow value and bitumen. Like that they can ask and ask you a question. Now see, Marshall stability and unit weight graphs are more or less same, increases then decreases. Okay, so if they are asking the shape, and if they are asking the graph corresponds to what, then they will not give Marshall stability and unit weight in the option, because both are same. You know? So remember, these graphs are important. You can see this type of question in the previous gate papers, then you will understand that either they can give the graph and ask which is that graph, or they can give the sentence and they can give 4 graphs in the option, they can ask you. Clear? In this, there is another concept, extra concept I can tell you. As of now, for gate exam, they have not asked that concept. One extra concept. If we are drawing these graphs, if I am selecting 3 graphs from that, Marshall stability, unit weight, and percentage air voids. If we are selecting these graphs, we can calculate what is this particular value of bitumen content or binder content. See, this is nothing but binder. We will be getting a value here. If I am simply denoting it as binder content 1, corresponds to this maximum Marshall stability value. Then here also we are going to get an optimum value. Suppose if I am putting B2. Here we don't have any optimum value. Now, so what we will do, in this percentage air voids, we will take the value 4%. Corresponds to 4%, what is this value? If I am putting it as B3. We have a concept called as optimum binder content. What is this optimum binder content? Nothing but we got one B1 here, we got a B2 here, we got a B3 here. What we will do? We'll take the average of those 3 values. Okay, B1 plus, B2 plus, B3 by 3. This is the optimum binder content. Remember, we are taking 3 graphs which are Marshall stability. Clear, everyone? Okay, so take that as an extra point. As of now, they have not asked. Take it as an extra point. Clear? Now we are moving into the next concept. Nothing but modified CBR method. Yes, take down the question. You just take all the data, then I will explain what it is. Once we have taken down the data, please let me know. Everyone. This question is going to be lengthy. A part of this can be asked for gate exam. or one value, which is nothing but from this table, we are going to calculate vehicle damage factor. Previously, they have asked like a lengthy question where we were allowed to take the scientific calculator in the examination hall. Now we don't have that. So they may not be asking that lengthy question. They will directly give, or this can be asked as a two separate question, 2 mark, 2 mark. Okay. So basically this can be corresponds to a 4 mark type of question. But since we don't have that much mark, they will not ask you lengthy question. Right. I hope you have taken the data already. Yes. If they are asking the question, which is the design traffic in million standard axle MSA or cumulative standard axle, remember about modified CBR method. So according to modified CBR method, the design traffic is nothing but 365 ADF into 1 plus R the whole raised to N minus 1 divided by R. 365 ADF into 1 plus R the whole raised to N minus 1 whole divided by R. This is the equation of modified CBR method. Little bit complicated, but once you are practicing the equation and solving a question, then it will come automatically. Don't worry. In this, see, in some solutions, maybe if you are referring some materials, in some solutions, they will give, simply, I'm telling, no need to separately calculate what is this A and what is D. In some material, they might have calculated by combinedly taking A and D. So in the in the equation, we have A into D now. So in some material, in their solution, they will take A into D together and substitute there. Sometimes they will calculate A separately, D separately, and substitute there. Okay. So no need to confuse by looking at the solution of some different institutes and confuse what is this A value, what is A value, why they have taken D along with A. Don't confuse, simply A into D we can consider together. Okay. Or separately also. It's up to us. Now, what is this A? What will be the future traffic when this road is open to the public? Okay, when this construction is completed, what will be the future traffic? That is nothing but this A stands for some anticipated traffic. Sometimes they will directly give that. Sometimes they will give the present traffic. From the present traffic, we can calculate the future traffic. They told that the present traffic is 6,380 commercial vehicles per day. CVPD stands for commercial vehicles per day. But this 6,380 is actually not the present traffic. That is according to the survey conducted 1 year before. It is 1 year before it was 6,300. But at present, it will not be. It will be definitely more than that. We don't know how much it is. And they are telling it is increasing at a rate of 5%. And the construction will take how many years? 3 years, which means 1 year before it was 6,380. At present, we don't know how much it is. The road construction will take again 3 years, which means 1 year before, now 3 years in future. So totally 4 years of gap is there between this already having count and the future traffic. Are you understanding? There are 4 year gap between this 6,380. So the equation is 1 plus R the whole raised to X in general, where X is the construction period, whereas we are assuming this P is the present traffic. But in such a question, either they can give the present traffic, or they can give directly the future traffic, or they can give some past data. So they have given this 6,880 as 1 year before. So what I need to do? This R value is given as 5%, substitute in decimal. So this X value will not be now the construction period. We have to take care of the past data. If they are giving that it is the present data, then no need to take this +1. If they are telling that traffic count has done 2 years before, then we have to consider that 2. In this question, they have given 1 year before. So take that as 1. Is it clear? Don't take it as what is that? See, design life is 15 years. Don't take 15 by mistake. It is the construction period. Okay. Since the data is of 1 year before, we have to consider that one also. Clear, guys? If you are calculating how much you are getting, 7755 approximately. 7755 approximately. You can take the accurate value 0.9 and something. It's up to you. So that is equal to 365 into 7755. So till here it is clear. Yes, very good. You can take 0.92 approximately, whatever. I'm taking this answer. Okay. You will be getting only one option in the given options. Don't worry. Now what is D? Given that it is a 4-lane undivided road. What do you mean by 4-lane undivided road? 1, 2, 3, 4. Okay. And in one-way direction, which means all the vehicles are going in one direction. That's what they were giving as 6380. This is why I told either we can consider 6380 here or whatever we calculated 7755. Okay, that also we can consider. That's why I told A into D you consider together. Finally, you check your answer. Don't compare the solution of any institute with your solution. Finally, you check your answer. Okay. Now, if it is in one way, if it is undivided, it is going to split it into 4 parts. And we have the lane distribution factor. If it is for single lane, it is 1. For 2 lane, single carriageway, 0.75. 3 lane, single carriageway or one way, it is 0.6. And for 4 lane, divide it is into D is equal to 0.4. So what you can do, I told you in the last year, another session we have done. I told you to watch that already. In that, I have taken a divided road, 4 lane instead of undivided, 4 lane divided road. Then I have given the traffic in both direction. Then what to do? Okay, you just go through that video. Then you will be getting different kinds of question. Okay, so in this question, whenever they are giving 4 lane in one way, the the D value will be 0.4. Sometimes if they can give in the question, if they are giving some value, you take as it is. If they are not giving, then remember that. Okay, if it is one way, sorry, if it is 1 lane, then D will be 1, 2 lane 0.75, 3 lane 0.6, 4 lane 0.4. Okay, now F value we have to calculate. Keep it there. This is what I told you. They will give in the question for 2 mark. This question I am just trying to incorporate more concepts into one question. That's why. Okay, so 0.4. Now F value I am keeping it here. Now 1 plus R. R is nothing but 5% given in the question. So decimal if I am taking, can I take 1.05 directly? Nothing but 1 plus R. Raised to N. And this N is nothing but our design life. Okay. What is that? 15 years. Okay. Don't confuse with this 15 and this X value which we are taking here. Don't confuse and make mistake. So here it will be 15 divided by 0.05. If you have any confusion with this 0.4, you just watch the video which I have done in the last year. I will give that as comment, or those who are watching the video, if you are getting that comment, you just comment in the comment box. Okay. So that others also will get. Now, how much you are getting now? Oh, sorry. F value we have not calculated. Most of the time they will give, or if they are giving a table like this, once they ask a question like this, but that time we were having the scientific calculator. Now onwards they may not be asking how to calculate the value from a V load or whatever load they are giving and some number or frequency. Properly listen how we are going to calculate. If they are giving some value, this F stands for vehicle damage factor. Okay, vehicle damage factor, load divided by standard load. Load divided by standard load raised to 4. This is known as 4th power law. Okay, 4th power law. Load divided by standard load raised to 4, multiplying with the corresponding frequency. What is the meaning of frequency here? What is the meaning of frequency here? Number of occurrence. Okay, corresponding how many number of times this particular load was there. I can tell this is load 1. Okay, first load. Okay, first load. plus similarly second load by standard load raised to 4 multiply with corresponding frequency, etc. whole divided by total frequency. This is how we are going to calculate the vehicle damage factor. Now, what is this standard load? This load, first load, second load, and corresponding frequency that they will give in the question. But this standard load they will not give. That we have to remember. The standard load is equal to, I can tell that standard load into two ways. Actually, we consider standard load as standard axle load is equal to 80 kilonewton. Sometimes they can make a twist by giving standard wheel load. We consider a standard axle as a dual wheel combination. Standard wheel load is nothing but 40 kilonewton. We assume the standard axle as two wheels here, two wheels here. So standard axle load is 80 kilonewton and standard wheel load is 40 kilonewton, means 40 on a dual wheel assembly. We'll consider it as a single wheel. Okay, don't think that it is two wheels, so why not it is 20 and all. We consider it as a single wheel, okay, equivalent single wheel. So standard wheel load is 40, standard axle load is 80 kilonewton. So if they are giving this load value, first load and all, in axle load, then standard load, denominator is to be considered it as 80 kilonewton. If they are giving the values in wheel load, we have to consider it as 40 kilonewton. So that is the twist which can come. Look at here. They have given wheel load in kilonewton. So tell me, what is the standard load which you are going to take? Everyone please comment. What is the standard load which you are going to take? Are you going to take 80 or 40? Everyone please comment. Very good. We have to take 40. Okay. The next twist, they can give the value in different units. What is the unit they have given here? Kilonewton. We know standard axle load is 80 kilonewton. Standard wheel load is 40 kilonewton. But if they are giving in other units, suppose they can give in tons. If they are giving in tons, correspondingly we will take 8.2 tons. Okay, if we are converting 8.2 tons and 4.1 tons. Okay, correspondingly you have to take the unit. Okay, and standard value. This is the twist which are going to come. Properly note down it. Okay, now the first load. What is the first load then? They have given a range, na, 30 to 50. See, I'm actually incorporating so many concepts into one question. Okay, that's why it is going to be like this. Otherwise, directly you can calculate. They are giving a range 30 to 50. Then what value you are going to take? Will you take 30? Will you take 50? Or will you take the average of 30 and 50? What you will do? Or will you take that maximum value 50? Very good. You have to take that average value. Whenever they are giving a range, we will take the average value for the calculation. Remember that, okay? So 30 kilonewton, 50 kilonewton, average value is 40 kilonewton. Now, since it is given that it is a wheel load, we have to take the standard wheel load is 40 kilonewton raised to 4. Now, what is the frequency they have given? Either they can give in terms of number or they can give in terms of percentage. Okay, whatever it is, we can take. So given that it is 35%, so what I'm going to take, either you can put 0.35 there or simply put percentage, 35, let it be. Now plus, what will be the second one then? Second one is going to be 60. No? What was the value? 50 to 70, means average will be 60. So 60 kilonewton, I'm not writing the unit again, divide by standard value 40 raised to 4, corresponding percentage is 50. Plus last one, average value will be 80 by 40, the whole raised to 4, corresponding value is 15. Now once you are substituting in percentage values, here also you put the same, that's all. Sorry, plus 50, plus 50, that's it. If you are putting 0.35, 0.5, 0.15, numerator will be 0.35 plus 0.5 plus 0.15, like that. We'll be getting 1. If it is percentage, if it is percentage, then we'll be getting 100, like that. Sometimes they can give some number, Then denominator will be that sum of the numbers. That's it. Okay, so this itself can be a 2-mark question. Okay, they can give a table and ask you to calculate what is the vehicle damage factor. Okay, tell me how much is vehicle damage factor you are getting. We denote it by F. You may take some time, no worries. Are you getting approximately 5.28? Yes, very good. Thank you. Approximately 5.28 you are getting. Yes, online calculator, you may take some time. No worries. Okay. Don't be hurry. Okay. Don't think that within 2 minutes I have to solve nothing. Take your time and do it. Don't make mistake. Now, if we are substituting back this 5.28 here, those who have not obtained that answer, keep it there. Don't worry. You can just practice it later. Now calculate this. How much you are getting this one? Complete one. I am getting a value 129.03 into 10 raised to 6. Very big value you are going to get. Okay, don't think that you are getting a big value, something wrong. No, very big value will be getting. You'll be getting, are you getting something like this? Right? Yes, thank you. So something like this around 129. The unit is cumulative standard axle. Cumulative standard axle. We can convert this into million standard axle. We know 1 million is equal to 10 raised to 6. So that is equal to 129.03 million standard axle divided with 10 raised to 6. Are you getting the same answer? 129.03. So can I select where is 129? It is not in the option. Then what to do? Is there any mistake I made in the calculation? Very good. What it is? Properly look at the question. One more data they have given. Load safety factor. In RCC and all you will study now. Factor of safety. We got 129.03 MSA. If we are designing for this value, it is perfect. No problem will be there for our road. But what we are going to do? We are going to be more safer side. We are going to design it for more traffic. So what we need to do? Yes, 129.03. Should I multiply or should I divide? That's it. I told you when we were discussing about application efficiency in irrigation. We are going to design for more traffic. Then the factor of safety is 1.1, something more than 1. So if I want to get more value, should I divide with 1.15 or multiply? Obviously multiply. Very good. As simple as that. That's it. So that is equal to how much, guys? Are you getting around 148? Are you getting around 148? Yes, very good. So which option I can select? Yes, very good, very good. All are commenting correct answers only. Yes, very good. Yes, I'm reading all your names, but I'm not telling. Okay, that's all. Because so many people are commenting. If I'm missing someone's name, then that is not good, na? That's why. Okay, meanwhile, sometimes I may mention also. Are you getting 150? Clear, guys? Is it clear? Yes, very good. Yes, 148. So according to option, we can select 150. Okay. So what actually we are going to do? Once we are getting this MSA value, we have so many table for different CBR value. So corresponding to a particular CBR value, we will check what is the corresponding MSA value. Then we will be getting the thickness of the pavement. Okay. And what is CBR? This is how we are going to calculate the CBR value. The load taken by, if they are giving some questions like this, load taken by specimen corresponds to 2.5 millimeter penetration. We'll divide with 1370. Similarly, 5 mm will divide with 2500. The most important thing, this 1370 is in kilogram. This also is in kilogram. These are the standard load, corresponds to 2.5 and 5 mm. Now tell me in which unit I have to substitute this numerator. Which unit I have to substitute this load taken by specimen? Everyone tell me. Yes, very good. Definitely that should be in kilogram because this new denominator is in kilogram. Now if I want to convert this into percentage, then we have to multiply with 100. Understood? Is it clear? Percentage CBR. Okay. Clear, guys? Yes. Now see, in payment design, I'm just telling some extra points, not that much complicated. You can study, self-study also. The rigid payment we are actually making as a combination of some slabs. So the gap between two slabs, we call it as expansion joints. So these expansion joints we are giving to take care of the expansion of the slab. Okay, very easy things. You can just study your own also, not that much complicated. And this expansion joints we will be giving some bars here. We call it as load transferring dowel bars. Okay, these are expansion joints. We call it as load transferring dowel bars. And if we are having two-lane road, this is actually the top view of the road. Okay, vehicles are going in this direction. Vehicles may be coming in this direction also. So if it is two-lane, then two separate slab we are going to give. To keep these slabs in position, what we will do, we'll give some other steel bars here. We call it as tie bars. Okay, we call it as tie bars. This is dowel bars. And this joint, there is a gap here also now. This joint we call it as longitudinal joint. We call it as longitudinal joint. These are basic things for 1 mark purpose. Now, to take care of expansion, we have given expansion joint. And to take care of contraction joint, what we will give? We will give some grooves here. See, like this. On this, I told you this is top view. On top view, we will not understand. So if I am just drawing the side view of this, cross-sectional side view of this, these are actually in terms of, in the shape of some groove. See, like this. Some grooves like this. Okay. We are going to fill it obviously. So these are known as contraction joints. What do you mean by contraction joints? Contraction or contraction, whatever. What do you mean by contraction joints? To take care of the contraction of the slab in winter seasons. Okay. And these are given in terms of grooves. Generally that thickness, suppose if thickness of the slab is h, generally we may give around h/3. Okay, it may vary actually. Sometimes we may give 1/4 of the thickness. Sometimes we may give slightly more than that also. Okay, on an average we may give h/3 of the thickness. And what we generally used to do, since we are removing the material from there and making a gap there, we'll fill it with some elastic material. We are actually removing some material so that the strength of that portion will decrease. Okay, so to take care of that decrease in strength, what we practically do, we'll give some dowel bars here also. At the center of this thickness, means such h/2. So this will be approximately h/2. So that may vary actually, depends on the design and all. Okay, around you can just remember. At the middle of the slab thickness, we will give some dowel bar. Why we are giving? Suppose if we are not giving any dowel bar, we are actually making a groove there by taking the material out. Whenever these vehicles are passing, there is a chance that cracks may happen here. Okay, to avoid that crack, what we can do? We can just put a dowel bar there. Clear? That's it. Those are the basic things you can just remember. That's it. Some extra points I will tell later if time is there. One thing you can remember, something important. What is the spacing between this expansion joint? If L is the spacing between the expansion joint, you can simply remember L into coefficient of thermal expansion into change in temperature will be equal to, we have a gap here. No? In this gap, we are going to fill using some elastic material. If I am telling that that gap is somewhat delta, for example, then this L into alpha into delta T will be delta by 2. This is somewhat important equation. You can just remember, if L is the length of the slab, or L is the spacing between the expansion joints, then we can take it as L into alpha, where is alpha is coefficient of thermal expansion. Unit is per degree Celsius. Temperature should be in degrees Celsius. Okay, so that degree Celsius and per degree Celsius will get cancels. The unit of L that you are substituting will be the unit of, or the value of gap of expansion joint you are substituting will be the unit of L you are getting. Properly remember, we have to tell divide by 2. Clear? So that you can remember. Okay, so remember those points. Then some extra points for theoretical purposes there regarding the stress in rigid pavement and all that I will tell you if time permits. Okay, now yes, coming to the railway engineering. If you are having any doubt regarding the regarding any topic, you can just comment. Okay, once the video is uploaded, I will reply you there. Now coming to the railway engineering, I'm just brushing up a few important points. Now see, they have given in the syllabus that geometry design of railway track. So we don't have to study the entire portion of railway engineering, but some points I'm giving you which can be appearing. Grade compensation, we have studied in highway also. We have studied an equation maximum of, the grade compensation we have studied in the highway engineering, which is 30 plus R by R, 75 by R. We will be taking the minimum value, and that equation will not be applicable in our railway engineering. Here it is completely different equation. 0.04 into degree of curve. If it is a broad gauge railway track, then meter gauge and narrow gauge, it keep on decreases. Very easy to remember. 0.04 percentage, 0.03 percentage, 0.02 percentage. Degree of a curve, they will give in the question. If not given, sometimes we used to take 1720 by radius. Sometimes we used to take 1750 divided by radius. It's actually both equation we can take, but whatever grade compensation we are calculating, practically whenever we are applying that, then we have to check with respect to what we have taken. So most probably whenever they are asking the question, they will give the degree also in the question. Either you can take 1720 or 1750. They will take care of that value. Okay, it's up to the designer what value he has to take. So accordingly, he will, while practically applying the value, he will take care. Okay, regarding what value he has taken. Okay, that's it. Now the gauge length is nothing but the clear gap between the railway tracks. Remember this, for broad gauge 1.676, meter gauge as the name indicates 1 meter, narrow gauge 0.762 meter. Now coming to the super elevation, this is also very important. Maybe they will ask question from this only. Actual super elevation we have, theoretical super elevation we have. We were not having like this in highway, only in railway. Now see this V square by 127R that we have already studied in highway. Along with that, a value will come G. Why this is actually happening? On highway, we have actually taken the tan theta value. This raising divided by this width. We have approximated to the width of the road. This tan theta we have studied in highway engineering, which is nothing but a decimal. That's why we told maximum value is 7% or 0.07. It's a fraction. But here, what we are doing, by super elevation in railway, we mean this raising. So what it will be? The V square by 127R or 225R we studied, that is equal to raising divided by width. So here this width is nothing but, I told you, this gauge length. So this G will come here. The equation will become G into V square by 127R for this raising. So that's what we are meaning by this super elevation in railway. That's why it is becoming G into V square by 127R. Is it clear, guys? Is it clear? More detailed explanation I have made in the last year video also. You can watch that also for better clarification or more discussion. Okay. Maximum value also you should remember. I have just written here. Most probably in railway, whatever value you are calculating will be coming less than this value only. Don't worry. Okay. But you just remember, at least you remember the value of broad gauge railway track. Okay. Now, what is the difference between this theoretical value and actual value? If we are using the average speed, then we are getting the actual super elevation. If we are taking the maximum value of speed, maximum permissible speed, we are getting theoretical super elevation. Now, what is the change, or how we can convert an actual super elevation, or how we can find if they are giving an actual super elevation, how we can find the theoretical super elevation? There is a simple equation. The actual value of super elevation plus the maximum Kant deficiency will give you the theoretical value of super elevation. Understanding? The actual value of super elevation plus Kant deficiency will give you the theoretical value of super elevation. What is this Kant deficiency? I will give you, or I will, yes, somewhere here I have written. I will explain that later. Sorry. Now, some space feed equation. It is almost outdated, but you can simply remember only for the broad gauge track. Just remember this equation. See, we are going to do questions based on this E actual and all. Okay, don't get confused. We are going to we are going to solve question. This is just an introduction I'm giving. Save speed, you just remember. At least, even though if you are not remembering the equation, at least for broad gauge you remember, and this note also you remember. If transition curve is not used, then the save speed will decrease by 20% or decreased to 80%. This can be asked for 1 mark purpose and all, or maybe for MSQ type of question. If they are asking which of the following statement is true, like that. Okay. Now coming to length of transition curve equation. This is not that much important, but you just remember. I am going to give a question based on this. In highway geometry design, we have studied equation for length of transition curve. There we have studied various equation, V cube by CR, En into W plus WE, 2.7 V square by R, and so on. Just go back to that and properly check. In railway, obviously, like we told, grade compensation, here we have different equation. We have to study. We are going to do a question based on this. Then we can explain better. And I told you E actual plus Kant deficiency is nothing but theoretical value of super elevation. In case if they are not giving you the Kant deficiency, we have to take the value from this particular data. Okay, broad gauge, we are taking 75 mm, meter gauge, and so on. At least you remember for broad gauge 75 millimeters. Some textbook says that it is 76 millimeters. No much change will come if you are taking 74 or 76, a fraction, only 1 mm difference. No change is going to happen. So you can just remember 75 millimeters. Okay. Now there is a concept of negative super elevation also. For negative super elevation, I have done a question in the last year video that you can check for the numericals related to negative super elevation. Okay. Now I'm giving you a question. Using the question, we'll understand better what is the super elevation, what is the actual super elevation, what is the Kant deficiency, what is the theoretical super elevation, and so on. Okay. You just take down the data. First of all, just take down the data. Then I will explain what it is. I hope you are following. I just have to finish the syllabus also, because it's very difficult to complete entire syllabus within this small time. Have you taken the data? Only 2 data is given. Radius is there, then average speed. Okay. So the equation of minimum length of transition curve we have already seen in the, once again. Yes. Here we have seen the equation of length of transition curve. That's what they are asking. So what is our task now? We have to calculate what is E actual. We have to calculate what is D max. We have to check what is V max and all. Okay. Now, as I have already mentioned, how to calculate the E actual value? Nothing but G into V average value of speed square divided by 127 R. Now properly listen guys, this G value, either you can take 1.676 meter, which is actually the clear distance, or 1.676 meter means 1776 mm. Okay, or sometimes we will take the sender to sender distance. Actually, the sender to sender distance will become 1750 if you are taking the value this plus 80 mm. If you are taking, you will be getting around 17. This is actually approximate value. 1 second, I will draw properly. We'll be having one rail here. We'll be having another rail here. This clear distance is 1.676 for a broad gauge mm. Okay. If you are taking the sender to sender distance, okay, you will be getting it approximately 1750 millimeter. So it's up to the designer whether he has to take 1676 or 1750, whatever it is. While providing the super elevation, he will take care from where we have to take that racing. So in some videos or in some NPTEL video or in some standard textbooks, some videos you will be getting 1676. Some materials they may tell that 1750. So what you do, better you take, see, even in my video, I have told that to take 1.676. That is also correct, but it's up to the designer. Better you take 1750 or 1.75 meter as the value if they are not giving. But what they will do in the question to avoid that confusion, either they will give that value when they asked in the gate exam, they have already given that, or if they are mentioning like this, consider where it is the sender to sender distance. If they are giving like this, then no confusion. You can directly take it as 1.75 meter or 1750 millimeter, or most probably they are going to give how much we have to take. Whenever they ask the question in gate or even in IAS, they have given the data directly. Okay. Now, if I am substituting, since they have given, I am substituting 1750, which is in mm. Remember, I am substituting in mm. Keep it there. They have given that the average speed is 60, 127. Radius is given as 800 meter. Now see, I told you, if they are giving in terms of degree, either we can take radius is equal to 1720 by degree, or we can take 1750 divided by degree. Both are actually acceptable. It's up to the designer. So in case if it is not given, better you take 1750 by D. In case if you are taking 1720 by D, then also it will be correct. They will take care that in the answer key. Okay, but better you take like this for better. Okay, it depends on the designer, but you take it. That's why to avoid that confusion, they will give in the question. Whenever they are asking, they are giving in the question. Okay, don't worry. So can you please comment how much you are getting this E actual value? Can you please comment how much you are getting E actual value? Yes, thank you. 62.007. You are getting in millimeter. Okay, just to take accurate value, I have taken into millimeter. Okay, better you also calculate in millimeter. Okay, so E actual value we got. If they are asking what is the actual super elevation, so this value we got. Okay, now the Khan deficiency, definitely they are not going to give that in the question. We are not seeing any value. And I told you in the previous slide, if they are not giving in the value, we have to go for this particular data. Now it is a broad gauge track. So which value I have to take? Which value we have to take? 75 millimeter. Clear? Okay. So the next data I'm substituting here. D max is also I got. If they are not giving 75 millimeter. Clear? Now the only unknown is V max. See, that itself can be a great question. Okay, what is the actual value of super elevation? Like that they can ask. How can we calculate the V max value? That's why we require this equation. I told you E actual plus whatever be the Kant efficiency. I'm simply putting D, okay? Whatever be this Kant efficiency is equal to E theoretical value. What is this equation of E actual? G into V average square divided by 127R. We already calculated. Then D max, I can also rewrite this equation as G into V maximum value of speed divided by 127R. Understanding? Now this part we already calculated 62.007 mm, and this value is 75 millimeter. Now can you calculate this? Simply add it. Now that is equal to G value 1750. We don't know what is this V max. That's what we want to calculate, divided by 127 into 100. Very simple. Okay, simply add it. If you are adding it, how much you are going to get? 137.007 equated to this, then we are going to get the Vmax value. Correct? How much is Vmax? Everyone, can you please comment how much is Vmax? Yes, thank you, 89. If I'm approximately taking, I'm getting around like this now. Yes, very good, thank you. Are you getting? See, actually speaking, there is a check here. We have to make sure that this value is less than V safe if they are asking what is the maximum permissible speed. But 100% or 99% it will be safe only. That's why this equation became outdated. If you are simply checking R minus 67, can you please check that equation I have shown you in the previous slide? So 4.35, 800 minus 67. Can you check how much it is? Are you getting around 117 point something? Enough? Obviously it is less. So actually speaking, we have to check the lesser value. If you are getting this value as, for example, 70, then we have to select Vmax equal to 70. But that's why I told always this V safe value, if you are using this equation, we are going to get a higher value compared to the Vmax value which we are calculated using this particular super elevation equation. Okay, that's why this equation is now almost outdated. You can simply check it and make sure that you are getting higher value. If you are getting lower value, that lower value only we have to take it as our Vmax value. Clear, guys? Okay, so which is lesser out of this? Which is lesser? 89.186 will be our Vmax. Don't think that we have to take the maximum. Whichever is lesser, that is our maximum. Are you getting 89? Clear? What was our question, by the way? Length of transition curve. So we got everything. Now directly substitute. Always remember, see, in different material you may get different equation like 7.2 E actual, 0.073 like that. Don't worry, that depends on in which unit you are substituting. This is the simplest way you can remember it. Otherwise, it's very difficult to mug up all the equation. 720, 7.3, 7.3. That's it. So once I am putting 720, E actual should be in meter. We got 62.007, that is in mm. Convert that into meters. Now this one 7.3. Everything should be in meter. So 0.075 meter it will be. Vmax is 89.186. 7.3. E actual we got 0.062. No? 62 means, yeah, into 89.186. So you just calculate everything. So the first one you are going to get it as 44.64. Second one you got it as 48.84829. 40.36. No need to calculate this third one, because see, if you are comparing the second and third equation, this is only the change. Obviously this is higher value, no? So no need to calculate the third one and waste your time. So finally, how much you are getting maximum? 48, enough? 48.8. Are you getting the same? Which option you are going to select? Everyone please comment. Are you getting the answer? Are you following me? Are you following me? Yes. Can everyone please comment so that I will understand you are following or not? Yes. Okay. Thank you. Very good. Okay. So these are the important concepts in railway engineering. For negative super elevation concept, I have done a question in the last year video that you can watch. Okay. Now, if I am going into the airport, okay, our time is almost about to be over. So what, little bit fast we can explain this, or don't worry, we have done a question. Yes, our time is almost about to end, but just I will be giving an introduction. We can fastly solve it. I have done a question for this also in the last year video. You can just watch that question also. Don't worry, okay? So that's why I told it's very difficult to compress all these things into less six hours. Now, lots of things we have to study. That's why. Okay, simply we can just fastly solve. Don't worry. Within 5 minutes or 10 minutes, we can just finish it. Last year also I have done a question. You can just watch it for better understanding. Now, the thing is, a new airport is to be constructed at a place. This question is somewhat tricky. That's why I just wanted to explain. Okay. Now, first of all, whenever you are getting a question, 3 data we require. What is the elevation of that airport? Then that's it. What is the elevation of that airport? Then what we require, what is the ART, atmospheric reference temperature? And then we require what is the gradient. Okay, sometimes if they are not given the gradient, we'll assume gradient is 0, means it is a flat ground. Then sometimes they will not give the ART, means atmospheric reference temperature. If they are not giving, they will give you 2 data, which is the mean average monthly temperature or maximum monthly average temperature. I mean, the average of maximum daily temperatures or the average of average daily temperatures, okay, of the hottest month. Okay, so here, are you able to find what is the value of the elevation? Those who don't know how to apply the correction, better you can watch the last year video. Can you find what is the elevation here? Can you find what is the elevation here? They have given the standard atmospheric temperature at this elevation, at the elevation of the particular airport is 11.88 degrees Celsius. Now, can you understand what is the elevation from this particular data? We know the standard atmospheric temperature at any particular elevation is equal to 15 degrees Celsius minus 0.0065 into elevation. Are you remembering this equation? So that 11.88 degrees Celsius will be equal to this data from where we can calculate the elevation. Correct? So this is what I wanted to discuss. Can be a tricky question like this. Are you getting, guys? Are you following me? Instead of giving you the elevation, they can give the data like this. Are you following me? Please comment yes or no, everyone. Are you following yes or no? Yes, very good. So that you are going to get 480 meter as the elevation. Right? Now we can solve within 5 minutes. We are going to solve it and winding up the session. Now what will be the elevation correction? Firstly solve, everyone. What will be the elevation correction? We know the elevation correction is equal to 7% for each 300 meter. So for each h meter elevation, we have to give this much percentage of basic runway length. Yes, very good. Basic runway length. So for each 300 meter, we are going to give 7%. So whatever be your elevation, that into h of the basic runway length. Henna? So you solve along with me. So 300, what it is, 480 meter divided by 300, multiplying with, they have given that it is 2100 meters. So this much percentage it is. So how much correction you are going to get? This will be around 11.12 now. Sorry, 11.2 percentage. 11.2 percentage of 2100 will be 235.2 meters. And that much correction, which means what will be the corrected length? Yes, thank you. What will be the corrected length then? We have 2100 meter already. We just have to add 235.2, so that we will be getting 2335.2 meter as the corrected length. But this is not they are asking. They are asking what is the temperature correction. But to calculate the temperature correction, this order we have to follow. This is very, very important. ART minus SAT percentage of this corrected length. Okay. This is why we have calculated this data, this length. This order is very, very important for us. So how can we calculate that the ART? Yes, thank you for commenting. SAT already given in the question 11.88 degrees Celsius. How can we calculate the ART? Sometimes they will give in the question. Sometimes we have to calculate. Nothing but the equation is the ART, atmospheric reference temperature equation, is monthly mean of average daily temperature plus monthly mean of maximum daily temperature minus the first value divided by 3. This is how we have to take. But if you are listening to the data, two set of value they have given now. Then which data you have to take? Which data you will take? Will you take this combination or will you take the green combination? Which combination you are going to take? Will you take this yellow combination or will you take this green combination? Very good, green combination. Why? Because it is we have to take for the hottest month. Generally, they will give only that data. I was just trying to make a twist question. Okay. So that data you have to take 28 and 32. Okay. I was purposefully making it more complex. That's all. So 28 plus 32 minus 28 by 3. Always remember your TM value going to be more. Okay. So this is 32 minus 28. That will be more value. Don't take 32 plus, because TA value will be always lesser than that of TM. Like that you can simply remember. Calculate it and tell me. Thank you. I'm already getting the final answer. Very good. This much percentage of 2335.2. Tell me how much it is. 407. Correct now? Very good. Thank you. So that we got the first answer, 407 point something. Temperature correction. Round off to 1 decimal. Up to you. Okay, 0.5 or 0.6. Getting now? That is temperature correction. Now, how can we calculate the corrected length now? New corrected length after temperature correction. We have 2335.2 meter already. We just have to add this 407.57. So that we are going to get 2742.77 meter. Correct? Yes. Are you getting? Here actually we have a check actually. This value 2742, this percentage change. Initially we have basic length 2100. Now we got this answer. This percentage change should be always less than or equal to 35%. You have to make sure that you are getting less than 35%. Okay. If not, you just keep this value. You just put that it is equal to X. You keep this as 35%. Then you calculate what is this value. Okay. What can be this maximum value? If you are calculating, you will be getting that less than 35% only most of the time. Don't worry. Understood? Is it clear? Now, what is the next question? Final corrected length. How can we calculate it? We have to apply the gradient also. If they were not giving the gradient in the question, this is the final corrected value. But gradient is given as 4%. We know for 1% gradient, we have to give 20% correction, then for 4% correction, how much we have to give? Sorry, 0.4, no? So for 0.4% correction, we have to give how much it will be then? 8%, no? Right? 8% correction will come. Correct? Yes. So just apply 8% correction now. 2742.77 multiply with 0.08 will be the correction. Now you plus add 2742.77. Your final answer will be. Are you getting this as the final answer? 2762 approximately. 2762 approximately getting. Yes, that's it. So that is our final corrected length. Okay. So actually speaking, I wanted to explain more things, but nothing but regarding some length of taxiway, turning radius of taxiway. You can just solve this question. You can just comment whatever you are getting for this particular question, length of, turning radius of taxiway. I'm just giving you the equation here. You can just take down the data and you can just solve this question. Only thing is, whenever they are not giving the data, or if they are giving only one particular data, suppose if they are giving only speed and friction, they are not giving the W value, they are not giving the T value, they are not giving the S value, then we will calculate based on only one equation and that will be our answer. Now, can you please tell me, we have to calculate the minimum radius and we have two equations. After calculating the value and we got two answers, this is actually 0.5. Okay, this is not yes, this is 0.5. After calculating two answers, if I want to calculate the minimum radius, what you will do? Will you take maximum of these two? Will you take minimum of these two? Absolutely, very good. We have to take maximum. We have seen like that so many concepts, completely opposite, ulta. So whichever is your maximum value, that is going to be your answer. Everything I have written here, you just take down this question, take a screenshot or take down this question. Please comment your answer. I will confirm. I also didn't calculate what is this answer. Okay, we can confirm in the comment box. Okay, not in the live chat, in the comment box. Once this question is, once this video is updated in the YouTube channel. Okay, one extra thing I'm telling here, in case if they are telling that it is a supersonic, sometimes the same airport or same runway or the same taxiway we can use for supersonic vehicle also, which means it is going to be very high speed. If it is a supersonic, then we have to consider, we are just extending it. We have to consider one more data, which is 180 meter. Okay. In other ways, if they are not mentioning it, we don't have to consider this. Okay. In general sense, till here only. Okay. If it is supersonic, we have to consider one more value, 180 meter. In the sense, suppose was first value you got 100, second value we got 140. Then we will not take as 140. 180 also we have to consider, then maximum will be 180, like that. Okay, then that will be our minimum turning radius. We just calculate it, everything I have written here. Then answer your, whatever be your answer, you just comment in the comment box. Okay, so that's it. That is the end of transportation engineering. I think we have discussed almost all the topic. Definitely so many parts are there which we have not we have not discussed, but they are unimportant, almost unimportant. But in between, in some years they have asked some questions also that you can just study from some by checking the previous gate papers or some materials, or in YouTube there are so many we have also done the solution for various questions on YouTube also. In case if you are getting any doubt, you can just comment in the comment box. Okay, we can just discuss that in the comment box, right? So I hope this video was beneficial for you. So thanks for everyone to join and being active in the comment box. If you are getting any doubt, please ask in the comment box. Definitely I will reply. Not only me, in all the video, definitely the corresponding faculties will be replying. Sometimes if you are not getting the reply in the same day, definitely within a few days, definitely the corresponding faculties will reply based on their availability. So I hope you got a confidence in transportation engineering, and please watch the video which I have done in the last year also. More types of videos we will be getting. Similarly, for hydrology irrigation, we have just completed yesterday. For hydrology and irrigation also, we have done a question in the last year. So I'm giving you, I'm making a request. You just comment the links which you are getting from the YouTube channel in this comment box, okay? Which I have made. I only made the session in the last year also. I will also comment. You also please comment in the comment box so that other students also will be getting that link. Let them also prepare and let them also get more score. Help your friends, help others. Definitely the Almighty will help you also. Okay. So thank you so much. So please don't forget to subscribe the channel and click on the bell icon so that whenever such videos are coming, you will be getting that notification. You will not miss the video. That's it. So share the video, share the link with your friends also. Thanks for joining. So after some time, you are going to get environmental. So please go fast and have your food and come back and join environmental. That's it. Okay. So thank you. Thank you so much. We are winding up the session. Have a good day. All the best for your GATE examination. Thank you.